We continue the exercises on the hybridization. We pass to exercise 18. What types of hybrid orbitals are involved in bonding in TeF4? So the Te, according to the periodic table, is in a group 6 or column 16. So the Lewis, if you draw Lewis structure, this is method number 1. The valence electrons are 6 for Te plus 4 times 7. So we have 28 plus 6, we have 34 electrons. So we draw F, Te, F, F, F. We have 4 bonds. 34 minus 8, 26. So we distributed 24 on the outer. And we have, this is 6 times 4, 24. So we have another 2 electrons on T. Okay. The form is A X4E. This is method number 1. This is the classical method used by the student. So EP around the central is equal to 5, 1, 2, 3, 4, 5, implies directly hybridization sp3d, or in some books we wrote it dsp3. This is the same. So the correct answer is B. We use the other method. We apply the relation non-bonding electrons equal valence electrons minus 8m. So it's equal to 34 minus 8 times 4. So it's equal to 34 minus 32. So we have 2 electrons. So we have E1, 1 pair. So the formula is directly A X4 E implies EP equal 5, implies hybridization directly sp3d or dsp3. So the correct answer in this case, the correct answer is B. We pass to exercise 19. What angles exists between sp orbital. sp hybridization means two lobes this is the central, this is sp. So the angle, the figure of repulsion is linear and the angle is 180 degrees. So the correct answer is B. Exercise 20. How many orbitals does sp3d2 hybrid orbitals set contain? Hybridization. sp2 sp3 d2 implies the number of hybrid orbitals is equal to 6. Is equal to 6. So how many rooms do we have? Do we need? Implies 6 orbitals. And the answer is E. What is the figure of repulsion of the 6 orbitals? The figure of repulsion is octahedral. This is exercise 20. The type of this exercise is application of the knowledge, applying knowledge. You can find the answer directly. We pass to exercise 21. Consider the below molecule and identify the correct statement. There is one carbon with hybridization sp3, 2 sp3, 3 carbons sp3, 4 carbons sp3, 6 carbons sp3. I will write the type of hybridization of all carbons. The first, EP equal 4 implies sp3. This carbon EP equal 3 implies sp2. This is sp3. This carbon is sp2. Pay attention, the double bond or the triple bond is counted as 1 EP. This carbon is sp. sp, since EP equal 2. sp2, EP equals 3, 1, 2, 3. sp, we have 2 bonds, and this is sp2. So the number of hybridization sp3 is equal 1, 2, 1, 2. We have 2 sp3, 2 carbon with sp3. sp2 1, 2, 3, 4. And the number of carbon that make sp hybridization 1, 2, 3. So in total, we have 4 and 3, 7, 8, 9. We have 9 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 carbons in this structure. 2 carbons make the hybridization sp3. 4 carbons make the hybridization sp2, and 3 carbons make the hybridization sp. So I will look to the statement. Statement 1, there is 1 carbon with sp3. This is false. State 2, there are 2 carbons with sp3. This is true. 3 carbons with sp3, false. 4 carbons with sp3, this is incorrect statement. And 6 carbons with sp3 hybridization, this is incorrect. So the answer is B. Exercise 22. How many sigma and pi bonds does the following molecule contain? To remember that sigma bond is a bond between orbitals along the axis. Pi bond is a bond which is overlap between orbitals. So I have to write the hydrogen, N hydrogen. So I have N, H, H, C, H, C, double bond O, O, H. I write only the bonds without writing the lone pairs, because the question is on the type of bond sigma or pi. So I write only the bonds. CO, N, H, H. This is sigma. The bond between N and H is sigma. A single bond is necessary sigma. This is a sigma. NC, one bond, so sigma. CH, one bond, sigma. CC, sigma. CO, sigma. And OH, sigma bond. CC, sigma. CH, sigma bond. Another CH, sigma bond. CC, sigma. CN, sigma. NH, sigma. And NH, sigma. So I write the sigma bonds directly. I pass now to the double bonds. In the double bond, one is sigma, the second is pi. This is sigma, and the second is pi. Pay attention, the double bond. We describe the double bond when we draw all orbitals. One orbital is sigma, one bond is sigma, the second bond is pi. In the triple bond, we have 1 sigma and 2 pi bonds. I will count the sigma. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have, and this is sigma, I have 16 sigma. I pass to the pi 1 pi in CO, 2 double bond. We have 2 double bond, so we have 2 pi. 1 pi in the first CO, and another pi is in the second CO. So in total, in this structure, we have 16 sigma bonds and 2 pi bonds. So the correct answer is E.